Hello, you're welcome to my channel Inside the App, and here we'll try to help you become an expert in blockchain and Web3. So in this video, we will explore the different variable types in Solidity and their specific use cases. Solidity is a popular programming language used for developing smart contracts on the Ethereum technology. When writing smart contracts, it is essential to understand the various variable types available in Solidity. These variable types determine the kind of data that can be stored and manipulated within a contract. So let's jump right on it. First, we have the boolean, which is a binary value that can either be true or false. It is expressed as bool. I can declare a boolean variable called has started and assign a value to it and say true. So booleans occupy 1 byte in storage, which is equal to 8 bits. Next, we have the integers. Solidity provides several integer types with different bit sizes. They include int 8, and name this A, int 16, int 32, int 64, int 128, and int 256. So these integers listed above contain signed integers, which means that they can carry negative numbers in these different sizes, which contain 1 byte for int 8, 2 bytes for int 16, 4 bytes for int 32, 8 bytes for int 64, 16 bytes for int 128, and 32 bytes for int 256. And then we have the unsigned integers, which do not carry negative values, and they include uint 8, uint 16, uint 32, uint 64, uint 128, and uint 256. And just like their counterparts, they occupy the same bytes in storage. The total range of value that can be held in uint 256 runs from 0 to the value you get when you resolve 2 raised to the power of 256 minus 1. The next variable type we have is the address type. So the address type is used to store Ethereum addresses. It can represent both externally owned addresses and smart contract addresses. I can declare an address variable, let's just say token, and assign a value to it. So I'm just going to copy the smart contract address of DAI stablecoin on Polygon, and I'm going to assign the address to it. Addresses contain 20 bytes value, and they are used to send funds and interact with other smart contracts in smart contracts. So next we have the bytes variable. The bytes type allows for the storage and manipulation of arbitrary binary data. It is commonly used to handle low-level operations such as hashing and encryption within smart contracts. There are also various variations of the bytes, just like we have in the integers. So we have bytes 1. I can name this M, which is equal to 1 byte. I have bytes 2, which is equal to 2 bytes. We have bytes 3, which is equal to 3 bytes, and so on. I think I missed an S here. And we have it down to bytes 32, which is equal to 32 bytes. I can declare bytes 32 variable here and assign a value to it. Let's just say 0x0. Yeah. So the next variable we have is the string. Strings in Solidity are used to represent sequences of characters. They can be manipulated using various built-in functions and operators. Solidity also supports string concatenation and slicing. So I can define a string variable here. Let's call it message and give it a value. Let's just say hello world like we did in our previous video. So strings are dynamically sized, which means to compute the storage value of a string, you need to multiply 2 by the length of that string and then add 32 bytes. Next variable type we have is the array. Solidity supports both fixed-sized and dynamic-sized arrays. Fixed-size arrays have predetermined length and cannot be resized once created, while dynamic arrays can grow or shrink in size. Solidity arrays vary from JavaScript arrays with regards to how variables are stored in them. So I'm just going to first of all define a uint type fixed-sized array. And let's say it's an array of size 5. And let's call this R1. I'm going to assign a variable. So since it's an array, I need to pass in values to it. So it can be 3, 94, 467, 7, 9,000. So as you can see, we can't store anything more than the size we've defined. Next, I'm going to define a string type dynamic array. So we can declare as many string variables as we want inside this string array. Since it's dynamically typed, it can keep increasing and reducing as much as we want to use it. And now with data structures, first of all, I'm going to start with structs. Structs allow you to define custom data structures in Solidity. They can hold multiple variables of different types and are useful for organizing and grouping related data together. So I'm going to define a struct and name that data. In this struct, we can have a string variable, which we're going to call name. We can also have an address variable, which we're going to call wallet. We can have a uint variable, which we're going to call age. And we can have a boolean variable, which we can call as paid. So in order to access or manipulate the data inside this struct, you're going to need to create a pointer in your smart contracts, which will enable you to do this, but we're going to learn this in our next video. So the next data structure we have is the enum type. Enums enable you to define custom types with a finite set of possible values. Each value in the enum has an associated integer value starting from 0, which can be used to represent different states or options within a contract. So I'm going to define my first enum. Let's name this mode. Since it's a data structure, it begins with a capital letter. So I'm just going to name my modes. Let's say hungry, happy, sad, and sleepy. So to access the values in this enum, you're going to have to create a pointer inside a function where you would have to use it. But in our next video, we're going to start dealing with more complex stuff. And lastly, we have the mapping. Mappings are key value data structures used to store and retrieve data efficiently in smart contracts. So there are two kinds of mappings. There's a simpler one and a more complex one, which I'm going to show you right away. So let's define the first mapping. Let's have the key be an address mapped to a uint. So this is the kind of mapping that you see in an ERC20 smart contract for balances. So it maps the address to balances of users. And then we also have the more complex mapping type. Let's just say a mapping of uint 256 to another mapping of string to, let's just say, data. So I missed an arrow here. So I'm just going to name this age to name to data. I mean, whatever that means. And so you have it. We've just gone through the different variable types and data structures in Solidity. Understanding the different variable types in Solidity is crucial for writing efficient and secure smart contracts. By utilizing the appropriate data types, developers can ensure proper handling of data and minimize potential vulnerabilities. Also remember that the size of variables in Solidity is measured in bytes, where 1 byte is equal to 8 bits.